In this question, it is given that let f takes the interval this to r be a continuous function such that f0 equal to 1 and 0 to pi by 3 f dt is 0, then which of the following statements is oblique are true? You have to find the correct choice. Before I do this question, I will say note this thing. Suppose fx is some continuous function in the interval a to b and the answer is coming to be 0. It surely means that between these two lines, the area bounded by the graph above x-axis and below x-axis are sure to be equal. For example, if these two areas are equal, then the value of a to b fx dx will be 0. It surely means that the graph will be cutting x-axis at least once in the interval a to b. In other words, I can say the equation fx equal 0 will have at least one root in the interval a to b. Note that equal 0 is possible in that case also if the graph of fx coincides with x-axis between a and b. That is, value of fx remains 0 between a and b. Keeping this thing in mind, it is very easy to see that 0 to pi by 3 fx minus 3 cos 3x dx is equal to 0 to pi by 3 fx dx minus 0 to pi by 3 cos 3x dx. It is clearly 0. This is also 0, and keeping this concept in mind, I can say that the function fx minus 3 cos is equal 0 for at least one value of x in the interval 0 to pi by 3. Second part also can be checked using the same argument 0 to pi by 3 fx minus 3 sine 3x plus 6 upon pi dx is clearly equal to 0 plus cos 3x plus 6 upon pi x 0 to pi by 3. That is equal to minus 1 plus 2 minus 1. That is 0. Hence, using the same argument, again I can say this equal 0 will also have at least one root in the interval 0 to pi by 3. And for C part, let me find the limit of limit x tends 0, x 0 to x f t dt upon 1 minus e to power x square. This is equal to limit x tends 0, 0 to x f t dt upon e to power x square minus 1 upon x square into x. And as you know that the limit of this part is 1, and we are allowed to take the limit of a part of the question if limit of that part is non-zero finite and that part is in multiplication or division with remaining whole question on which limit is operating, because the limit of this part is 1 also, and this is in multiplication or division with remaining whole question where limit is operating. Therefore I am allowed to take the limit of this part. Note that if you don't take care of these conditions, you may get wrong answer. And this is equal to minus limit x tends 0, 0 to x f dt upon x. Note that the limit of numerator is sure to be 0, because as you know that for any function hx dx represent the area under the curve within the limits a to b. But in case b is tending to a, then the area will be surely tending to 0 whatever is the graph. If b is tending to a, the limit of this part will be surely 0, and here x is coming nearer and nearer to 0, therefore the limit of numerator is sure to be 0. Denominator is already tending to 0, hence I can say this is in 0 by 0 form. Therefore minus, now using L'Hopital's rule, I get fx into 1 upon 1, and because the function is continuous given to you, hence it is equal to minus f0, and f0 is 1, hence I get the answer minus 1. And lastly, for the choice D, limit x tends 0, 0 to x f dt upon x into sin x upon x. Limit of this is 1 known to us, and because again this is in multiplication with remaining whole question on which limit is operating, and the limit of this part is 1, that is non-zero finite, therefore I am allowed to take the limit of this part. Hence I get the conclusion that this is limit x tends 0, 0 to x f dt upon x. Again, as in the previous case, it is tending to 0, hence using L'Hopital's rule, I get fx upon 1, which is f0, which is 1. This is equal to this because function is given to us continuous. Hence I will say D is wrong choice.